Hello there and welcome to a brand new lesson. This is Hack Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at question 4b of the BECE 2026. It is on trigonometry. By the end of this lesson, you should be able to draw and label a right angle triangle from a word problem. You should be able to use the trigonometric ratios to find unknown sides. And finally, you should be able to apply given values of tan 60 and cos 60 correctly. On our left-hand side are solutions to the trial questions of question 4a. You can always compare that to your solution and you do the necessary corrections if the need be. Without much I say, let's quickly look into it. So let's look at our question. A painter places a ladder against a building at a window. The angle the foot of the ladder makes with the horizontal ground is 60 degrees. If the distance from the foot of the ladder to the base of the building is 5 meters, we have to illustrate the information in a diagram, and then we have to find correct to one decimal place the length of the ladder, and secondly, the distance between the window and the foot of the building. You have to take tan 60 as 1.732 and cos 60 as 1 over 2. Now, this is a question that involves triangles and then trigonometric ratios, specifically what we call the SOHCAHTOA. So let's quickly look at the concept here before we come back to the question. So to understand the concept, we need our right angle triangle. A right angle triangle is simply a triangle with one of its side being 90 degrees. So this is our 90 degrees over here. Now, if we are calling one of its side to be 90 degrees, then the side that is opposite the 90 degrees is called the hypotenuse. Or we sometimes say it is the longest side of the triangle. The name of the hypotenuse never changes. The hypotenuse is always the hypotenuse because it is the side that faces what we have here as the 90 degrees. So we have our hypotenuse here. So let's label that as H, H for hypotenuse. Now a triangle has three angles. Okay, so if I'm labeling this angle here as my alpha and this angle as my beta, the remaining sides of the triangle, that is the arms, get their names with respect to the angle we are talking about. So if my reference point is this angle, then if I'm to draw a line to bisect this angle, you see it touches this particular side. You see, so if it touches this particular side, we call it the opposite side. That is the side that when you bisect this angle, that line will touch it. So this white side is called the opposite of the angle. Okay, so if this angle is my reference point, we are saying the hypotenuse is always the hypotenuse. But then the side opposite our reference angle becomes the opposite just from the English word. So we have opposite here, and then the remaining side becomes the adjacent because it is adjacent to this angle. That aside, if this angle was our reference point, then if I'm to bisect it as well, look at where the line faces. It faces this particular side. If this is our reference point, this side here now becomes our opposite and this becomes our adjacent. You see? So the opposite and adjacent are relative. Depending on what you have in your question, you would get to know which you are going to use as your opposite or adjacent. On that note, let's focus on this angle. Now, if this is our angle, for trigonometric ratios, we have the sine, we have the cosine, and then we have the tangent. So using this acronym here, which is the SOHCAHTOA, it says if you want to use the sine, we use the so this is simply the sine, S for sine, and then the C for cosine, or simply the cos, and then your T is the tan or the tangent. Okay, so if this is our reference angle and we want to use the sine of this angle, alpha, we say it is simply the opposite side. So the side that is opposite, whatever measure you have here, the opposite over the hypotenuse, the measure of the hypotenuse. If you want the cos of alpha, then that is going to be the adjacent. So it's rather this line, which is our adjacent over the hypotenuse. And then the last trigonometric ratio is the tangent. So the tangent of alpha is what? OA. That is the opposite, which is this side here, opposite over A, which is adjacent over A. You see? So with all of this, we'll be able to solve our question. Now that we understand the concept, let's look at the question. So back to the question, it says a painter places a ladder against a building at the window. So just for illustration purpose, this here is going to be my building, and these are the windows. Okay, so this is my building, and these are the windows. Now the painter places a ladder. So if this is the window he placed it on, then I'm just going to draw a ladder here. So this is going to be my ladder. Okay, or we can just simply represent that here. So this is the ladder he has placed on the window. Now, since this is the ground, we'll just add another line here to show that that is the ground. The angle, the foot of the ladder, this is the ladder. And we are saying that the angle it makes with the ground. Okay, so the angle this ladder makes with the ground is what we are saying is 60 degrees. If the distance from the foot of the ladder to the base of the building is 5 meters, so this is the foot of the ladder and this is the base of the building. We are saying this distance here is actually a 5 meters. You see, that is all. Okay, but in exam hall, I wouldn't expect you to draw your building like this. You can just use simple lines. So we are going to get our building to be a straight line, and then the ladder also comes here, and then we have our ground as well over here. A simple triangle will do. And then you then come and do your label. So you have your 60 degrees right here. Then the length of the foot to the base is a 5 meter. And I think that is all we're given in the question. 5 meters. That is all we're given in the question. So this becomes solution to I. That is the first part of the question. Now it says you have to find correct to one decimal place the length of the ladder. So let's represent the ladder with what? L. And if you want the length of the ladder, looking at the trigonometry ratios we have, it says so, ka, and then toa. At this particular moment, this is our angle of focus. And looking at the variables we have, if this is our angle, then this becomes the adjacent. So we have A, and then we have A. And we also have the hypotenuse. So we have H as well, you see. So we don't have a complete set for sine, and neither do we have a complete set for tangent. Hence, we can use the cosine. So we say the cosine of 60 degrees is equal to adjacent over hypotenuse. So adjacent becomes our 5 meters over the hypotenuse, which you don't know as L. It is then with this that we'll do our substitution and make L the subject. That is the length of the ladder. From our question, we know the cos of 60 is half. So we do that substitution here. So we say 1 over 2 is equal to 5 over L. If we cross multiply, we have 1 times L, which gives us an L, is equal to 2 times 5, which would also give us a 10. And we attach the units to it. So the length of the ladder is 10 meters. It says to 1 decimal place, so 10.0 meters will be fine. That becomes our answer to the second part of the question. The third part of the question says the distance between the window and the foot of the building. For the second part, you can solve it in two ways. The first one, for the tangent, it deals with the opposite and the adjacent. And we already know what the tangent of 60 is. So we can easily make the opposite the subject. What I mean is the tangent of 60 degrees is going to be equal to opposite over adjacent. So the opposite side, let's make it height. So opposite side, which is h, over the adjacent. The adjacent in this case is R5. Making h the subject, you have your h, which is equal to 5 tan 60 degrees. And tan 60 from the question was given as what? 1.732. So 1.732. And evaluating that is then going to give us an 8 point. Well, let me illustrate that for you. So we have 1.732 times a 5. So 5 times 2 gives us a 10. We have a 0, carry 1. 5 times 3 gives us a 15. 15 plus 1 gives us a 16. So 6, carry 1. 5 plus 7 gives us a 35. A 35 plus 1 gives us a 36. So 6, carry 3. Then 5 times 1 gives us a 5. Then plus our 3, we have a 8. Not forgetting our decimal point. But the question specified that we should work in 1 decimal place. So our height is equal to 8.7 meters. That is when we round it. As simple as that. You could also use the Pythagoras theorem to solve, especially since you've already found the length of the ladder. So this becomes your hypotenuse, and then you have your adjacent. And using its formula, you would simply say L squared is equal to the 5 squared plus h squared. So let me know at the comment section if you're able to use this formula to also arrive at the answer. But we are done for this question, and as usual, I'll give you some exercises so you try on your own just to test your understanding. So here are 5 questions. You can pause and then attempt before moving on. As usual, the solutions will be presented in the next session, where we look at question 5A. I do hope this lesson was useful. If there's any issue of concern, you can always let me know at the comment section. This is Happy Your Numbers, where we learn maths the easy way. If this is your first time on this channel as well, and think it will be of help to you, you can choose to subscribe if you so the way, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.